So like I said, we're going to work these examples. So the first thing you need to do is write down these two examples in your notebook, skip a little space, and then we will work those. Also, in your agenda, there is a page that has conversions, English to metric, metric to English. So what I would like for you to do is, if you have your agenda here, go ahead and take that out. Now, if you look on that page in your agenda, what I'm doing is I have 4.5 pounds. And I'm converting that to kilograms. So I'm going from an English to a metric unit. So what I need to do is I need to set up a conversion box as so. I set up my conversion box and I want pounds to cancel. Okay? I want pounds to cancel. So I put pounds on the bottom. I'm going to put kilograms on top so that my pounds here will cancel and my final answer will be in kilograms. Now, we can do this a couple of different ways. The first being if I follow in my book here, in my agenda, it says pounds to kilograms, I multiply by 0.45. So 0.45 kilograms is equal to 1 pound. So if I am doing this now, I would take the 4.5 and I would multiply it by 0.45, and that would give me a value of 2.025 kilograms. Now, we've talked about significant figures, right? Do I have sig figs there? Okay. Do I have sig figs here correctly? No. No, because we're dealing with a calculation that's multiplication and division. Okay? We're dealing with a calculation that's multiplication and division. So I have right here 2 sig figs. Right here I have 2 sig figs. So I've got to make my value 2 sig figs. So that 2 doesn't round that 0. So my correct answer for this is going to be 2.0 kilograms. Okay, 2.0 kilograms. Yeah. 2 point, not have the 0, that would only be 1 sig fig. Okay? If I would just have 2 point, it would only be 1 sig fig. I need 2 sig figs. Yeah. You don't count the 1. Okay? Don't count that 1 below. Now, there's another way that you could do this one, because if you would research on the internet and say, okay, pounds to kilograms, it might tell you that 1 kilogram is equal to 2.20 lbs. Okay? It might tell you that. So, if I were going to do this in a different way, and I'm just showing you that my numbers are all going to work out the same. So let me do this in another way, because I'm using a different conversion factor. There could be more than one conversion factor. So I have 4.5 pounds. Now my conversion factor I'm using is right here. I'm still going to line up pounds on the bottom, kilograms on top, because I want them to cancel to give me a kilogram. Now, why does that cancel? Why does it cancel? Well, what is an LBS over an LBS? What's that equal to? 1. Anything over itself is equal to 1, correct? That's why those cancel. Now I fill in my numbers. 1 kilogram is equal to 2.20 pounds. This is a little bit different than the last one because, once again, I multiply by stuff on the top, I divide by stuff on the bottom. So, I take 4.5, multiply it by 1, and then divide it by 2.20, and that gives me a value of 2.045. Now, when Austin asked me that question before, okay, why don't you count this one as 1 sig fig? We go back to the problem. What was given to me? How many sig figs were given to me in the problem? 2, right? That's why we go back to 2. If I convert this back to 2 sig figs, is my answer the same no matter which way I did that? Yeah. Okay? Yeah. Now, let's look at the next one. 3.0 miles to kilometers. Okay? So I have 3.0 miles. I want to convert it to kilometers. So I'm going to put kilometers on the top, miles on the bottom. Can anybody think, does anybody know what the conversion factor is? Kilometers to miles, miles to kilometers? Okay? 1 mile is equal to 1.61 kilometers. So 1 mile is equal to 1.61 kilometers. If I would look, I would say that's probably, yep. If I look in my agenda, yeah, that is actually there. And once again, if you can't find the conversion factor, Google it. Excuse me. If you can't find the conversion factor, Google it. It'll be there. My miles cancel. So what is my label going to be? Kilometers. When I do my math, I take 3.0, multiply it by 1.61, and how many sig figs do I need? I need 2 sig figs. Go back to my original problem, 2 sig figs. So when I do that, when I did my math, I came up with a value of 4.83. So my answer is going to be 4.8 kilometers. So 3 miles is equal to 4.8 kilometers. Do we understand the conversion boxes that I'm setting up here? Because, I mean, it's the factor label method. It's going to be important with what we do here in chemistry. Okay? Here are the next 2. Go ahead and copy those next 2 down, and then we will work them. Now, if you are looking in your agenda trying to figure this one out, you're not going to find cubic inches to milliliters, are you? Okay? What did you find if you look in your agenda? What did you find? Yeah, Taylor? Cubic inches to cubic centimeters. Okay? Let me tell you something that you're going to need throughout the year here. Okay? Let me tell you something you're going to need throughout the year here. 1 cubic centimeter is equal to 1 milliliter. 1 cubic centimeter is equal to 1 milliliter. So if I convert this into cubic centimeters, I'm actually converting it to what? Milliliters. Okay? I'm actually converting it to milliliters. So let me get that out of the way here. 18 cubic inches. I'm going to convert that from cubic inches into cubic centimeters. My multiplication factor that I see is 16.39 over 1. Now, how many sig figs did my problem give me? How many sig figs are right there in 18? 3. 18.0 is 3, right? So when I do my math, I make sure that my inches cancel. 18.0 times 16.39 gives me 295.02. So 3 sig figs are 295 cubic centimeters. But like I said before, that'll tell me that it's also 295 milliliters, because 1 cubic centimeter, again, is equal to 1 milliliter. Let's go on and look at number 4 there. 13.0 meters to feet. 13.0 meters, and I want to convert it to feet. Do I have a conversion factor? Meters to feet? Okay. Meters to feet. Yes, I do. Okay. I look there, and I say, okay, I want meters to cancel. I want feet to be on top. So my conversion factor, meters to feet, is 3.28 feet in 1 meter. So a little bit over 3 feet to a meter. So I take the 13.0 and I multiply it by 3.28, and I get a value of 42.64. But I need 3 significant figures, so my conversion's going to be 42.6. What's my label going to be? What's my label? Feet. My meters cancel, gives me feet. When I'm showing an answer, folks, my final answer, I always put it in a box, too. So when I'm showing my final answer, I need to put that final answer in a box. All right, let's move on to my next one. My next one is a temperature conversion problem. Now, when I'm doing temperature conversions, I need to have my conversion factors, how to get from Fahrenheit to Celsius and vice versa. As I look at my first one, to go from Fahrenheit or Celsius to Fahrenheit, degrees Fahrenheit is equal to 9/5 times degrees Celsius. I'm going to put that in parentheses, put it in brackets, so I make sure I do that first. And then I'm going to add 32 to it. So when I substitute my value here, my degrees Celsius was 10.0 degrees Celsius. So I take 9/5, which is equal to 1.8, 9/5 times 10. That gives me a value of 18. I add to that 32, and I come up with a value of 50. Now, Ladies and gentlemen, do I have the correct number of significant figures? How many sig figs do I have there in my answer? Right there? Right in there? This is 2. This is 1 sig fig right now. I need to have 3 sig figs. Okay? So what I'm going to do to get that 3 sig figs, I'm going to make that into 50.0 degrees Fahrenheit because I needed to have 3 significant figures. So I had to put in the zeros in order to get 3 sig figs. Questions on that one? All right, let's move to the next one here. Okay? I'm going to degrees Celsius, so this is a different equation. So degrees Celsius is equal to the degrees Fahrenheit minus 32. I have that in parentheses because I need to do that first. If I don't do that first, and I multiply and put it into my calculator without doing the subtraction first, it's going to screw everything up based on, please excuse my dear Aunt Sally. So I have to have those parentheses there. So if I'm looking at this, my degree Fahrenheit is 113. So I take 113, subtract 32, and that gives me a value of 81. Then I multiply that by 5/9, and I come up with a value of 45 in my calculator. Once again, do I have the correct number of sig figs that I need? Do I have the correct value of sig figs? I only need 2. I only have 2. I needed 3. So when I convert that, 45.0 degrees Celsius. My third problem here. Now we got this guy Kelvin. Notice, does it say degree Kelvin? It doesn't. It doesn't say degree Kelvin. So, it's just Kelvin. In order to go from Fahrenheit to Kelvin, I have to first convert to Celsius. So, that's just like the problem I did above. Degrees Celsius equals Fahrenheit minus 32. So I take the 68, I minus 32, then I multiply that by 5/9. 68 minus 32 gives me 36. Multiply that by 5/9. It gives me a value of 20. 20 degrees Celsius. Can anybody remember from the video, what is my conversion factor to get from Celsius to Kelvin? You should have that in your notes somewhere. How do I get from Celsius to Kelvin, Mackenzie? I add 273.15. So, when I add 20 to 273.15, I come up with a value of 293.15. And if I were going to sig fig this, how many significant figures do I have? How many do I have in my problem? How many should I have in my final answer? 2, because I only have 2 sig figs right here. 68's only 2 sig figs. So, how am I going to get 293.15 into 2 sig figs? I could either use scientific notation, but I think it's just easier to do this. There I have 2 sig figs. Here's my placeholder. Put my label on it. So my correct answer in significant figures would be 290 Kelvin by having 2 sig figs. Okay. Now this last one I put here, I put this last one on here just because it's a good trivia question to know. Okay? It's a good trivia question to know, and I'll show you why. Negative 40 degrees Fahrenheit, and I'm going to Celsius. So, to get degrees Celsius, I take my degrees Fahrenheit, I minus 32, put that in parentheses because I have to do that first, and then I multiply by 5/9. Well, negative 40 minus 32 gives me negative 72. If I take negative 72 and I multiply that by 5/9, I come up with a value of negative 40 degrees Celsius. Now, why? Why did I say that's a good trivia question? Okay. What is the question? What do you think the trivia question is? Okay. Actually, what the trivia question is it'll ask you, when is the Celsius scale the same as the Fahrenheit scale? Okay. Most people think, well, they're never the same. They're different scales. Okay. Where are the values the same at? Negative 40 Celsius is equal to what? Negative 40 Fahrenheit. That's the trivia right there. The only place where Fahrenheit and Celsius are the same is negative 40. I've actually seen that on Trivia Crack, okay, when I played it. Now, let's talk now about accuracy and precision. Accuracy and precision. Now, did you write down from the video what accuracy is? What is accuracy? Review your notes. You should have it in there somewhere. What is accuracy? Anyone? 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 What is accuracy? Yes, Medina. Okay, the ability to hit where you want to hit. How close are you to the accepted value? Obviously, on this particular slide here, I'm dealing with bullseyes. Okay? So my accuracy is going to be, how close am I to the bullseye? What is precision? What's precision? Yeah, Austin? Yeah. How close are they grouped? Okay, how close are they grouped? So I'm looking at this, okay? I'm looking at this, and I say, okay, accuracy, precision. How close are my first one? I'm on the first one here. How close are these to the bullseye? Are they very close? Not really. So, I'm not accurate. I'm not accurate. Are they grouped, though? Yes. So, we got a check mark on precision. That's very good grouping, but it's not very accurate. Now, I look at my second one. Okay? Are they pretty close to the bull? Yeah, they're pretty close to the bull. So I'm going to say, yeah, that's pretty good accuracy. Are they grouped, though? Are they grouped together? No, they're not. So my precision is not there. That one I'm pretty accurate, but I'm not very precise. Let's look at the third bullseye. Is it very accurate? No. I'm bad on accuracy. Is it very precise? No. I'm bad on precision. And the last one, what do you think? I'm accurate, yes. Give me a check on accuracy. Give me a check on precision, too. Because they're grouped good, and they're grouped pretty accurate to that bull. All right? Now, when we are trying to determine whether something is accurate, we use what we call error. And we're going to talk about absolute error, which will lead us right into percent error. You do not have these slides in your notes, I don't believe. These weren't on the video, so make sure you copy this down. The absolute error is calculated by subtracting the experimental value from the theoretical value. It's also maybe called the accepted value. So absolute error is equal to experimental minus theoretical. That leads us now to percent error. So go ahead and get this baby into your notes. Now the percent error is equal to the absolute value of experimental minus theoretical. Okay? Well, what is experimental minus theoretical? That's the absolute error, right? So I take the absolute value of the experimental minus the theoretical, divide it by the theoretical, multiply by 100. Okay? Experimental minus theoretical divided by theoretical, multiply by 100. That will give me the percent error. Okay?